theta. Okay, that's why I suppose we should solve this earlier. R3, okay, R3, and this basically we can solve it. I think it's not that difficult. I want you to handle this problem. Earlier we said it. Okay, this one. Okay, in order to solve this portion, okay, this one, when we substitute here, okay, I just finish it up, this part. Okay, okay, this is 2 2, okay, 1 to the 0, minus 2, can I leave it this as a 4? Then I just continue here, then I just, because purposely I'm under to do that. Okay, when you solve this part here, this is cos, then you get a u, right? You get a dz, this part. Okay, I'm u, but you cannot solve when you solve it that dz. Okay, u for the cos 2. Okay, when you substitute, you get a 2. It's a 2 pi over 0, right? And over here is a 2. Okay, and you cannot use u, instead you need to go back to the sign again, you just convert. Similarly we're going to use this part again, the same model that we're going to use. Okay, here sine theta 2, okay, is 2 divide with the 2. Okay, divide with the 2, and then okay, this one, okay, sorry, this one is a pi over 2 0 and dr, and okay, the theta, you need to substitute the theta and you can solve it. I'll give you 6 pi minus 2 as a solution. Just quick solution kind of things. Okay, if I made a mistakes, please let me know also. Just I'm solving again this solution, but I got only solution. I don't want to keep the steps because I wanted to explain this in the detail. I always, when I start doing, I'll try to myself complete this. I always will have my answers only with me. Okay, with that we already completed what we call as a cylindrical. Okay, cylindrical is a little bit solid. I will give you more example later. Okay, we're going to learn more example here later, but the most important things, you just get the idea first. Okay, now the last one is a spherical coordinate. Okay, spherical coordinates, it will take some time for you to digest the spherical coordinates. Spherical coordinates works, please pay some attention, please. Okay, very important. Okay, you see this, how am I creating the coordinate system here? Okay, the coordinate system, how the coordinate system works: z, x, y. Okay, we use a similar model to the way that we are solving. We call this is theta. I'm calling this is a theta. Okay, we are using one arm system. Okay, it's a kind of one arm. Actually, we're going to use this as an arm. The arm can go here or here. Okay, up, down, and rotate like. Okay, it will go like that. Okay, we're going to use this one arm system to plot this coordinate. This arm actually control the z, okay, and the horizontal. Okay, this span, for example, you see this. Okay, usually I use my arm to show you. Okay, this is we're going to use this concept. Okay, the pan, for example, it will work, okay, from vertical, okay, from ground to up, okay, and it will use ground, okay, like that. You're going to build this. Okay. Okay, now see how are we going to do this. Okay, in this case theta, okay, and we're going to build another one more. Okay, we're going to use rho. Okay, rho. Then this is a pi. Use a pi. Okay, use a phi. We're going to use a phi to calculate. Then this is a theta, this is a theta, this theta, this is phi, different. Okay, in order to do this, okay, we're going to use 3 coordinate based system. We're going to combine the cylindrical concept or polar coordinates here. Okay, for the base is a polar base. Okay, we're going to use a polar base. On the top we're going to use the rest. Okay, I know some of you still didn't get it yet. Okay, don't worry. Okay, we just go step by step. I'll just take up one by one to go. We're going to use this arm, one arm. I already say we're going to use one arm system. Okay, the radius of this is a rho. Okay, okay, then we're going to use, okay, you may say, can I use R? No, you sometimes you tend to get confused with the cylindrical system, therefore I just avoid R here. Okay, I'm avoiding R. Later I'll try to introduce the R, where the R will come in. Okay, but first I want you to use this. We're going to use this as our radius. Okay, this is a 1 radius. Okay, now we're going to use come up with the one system we call, okay, you look at this one. Okay, you look at this one. When this one, this radius, okay, this arm fall to the ground. Okay, you imagine this arm, this is one arm. We are using one arm which going to plot the whole thing. Okay, is fall to the things one by one we go. Okay, when it fall to the ground, okay, here this one, okay, we can see we're going to use vertical. We're going to use vertical here. I use red color. It use a vertical horizontal, sorry, this is a horizontal movement of the arm. Okay, this arm, horizontal movement of this arm. Okay, and this one is a vertical movement of this arm. Okay, therefore we're going to use phi here. We're going to use theta for the horizontal. Okay, therefore, okay, the first thing we're going to use R, X. We already learned before, right? For the vertical d theta, we learned this before, right? Theta I already introduced to you. X will represent as what do you call R cos theta, right? R cos theta. If you bring it this to the vertical, we already learned for the vertical is X is R theta and Y is R sine theta. Okay, now what are we going to bring here? Okay, look at this one. When I try to bring from here this side to here, it will be the logic that you're going to bring it down here is what we call as sine R cos theta, R sine theta. Okay, we imagine this one something, then we're going to combine. Okay, we're going to combine this with the what we call as a sorry, okay, we learned this. Okay, we learned this part basically. I forgot to explain this part first. Okay, let me I put it this part first. Easy. Okay, when I see this part here, this one can be referred as Z can be referred as a rho what? Rho cos phi. Are you agree with me? Okay, if I refer this part, okay, this is, I can say Z equals to rho cos phi, right? Okay, this is no doubt. What about this? If it is a straight line, which I going to bring it this down here, okay, which I going to bring it this down, and I going to use it this as a standard. Therefore, in order to bring this here, this part here, this will be called rho sine phi. Okay, rho sine phi. Okay, when I bring it this down, okay, this is the what we call as a, this is a kind of R. Imagine, you can imagine this as a R, which is phi sine rho sine phi. Okay, you can bring it this down again. You can imagine this R. This is, you can see now, we are now into the polar coordinate ready. Okay, for the horizontal basis, the R, we just bring it down, the same thing here to the rho sine phi. Okay, if this is the case, now we refer this one, okay, this arm here with this R equals to phi sine rho sine phi. Okay, this is how we refer to. And on the top for the Z, we refer to this one. Okay, now as we know, when we move to X coordinate, if I wanted to find the X coordinate anywhere, okay, therefore the X coordinate that I refer here is XR, right? Now you can see the R, I place this whole thing inside. The X is here, sorry, R, okay, then the whole equation here become like this. X, R is a rho sine phi cos theta, Y become rho sine phi sine theta. Okay, can you get me? And the Z is rho cos phi. Can you understand this portion? Okay, so not that clear. Okay, again, it's important for you to understand this process again. Okay, in the polar, this is the polar, right? This is a polar coordinate. Okay, polar, we already learned. In the polar, we learn X is a R. R is a whole thing, right? That ground cos theta. Y is a R sin theta. Okay, this is what we learn in the polar coordinate. What? This is the horizontal reference of the circle. For the horizontal reference of the circle, we use one arm system here. What we call is a rho. See, I'm bringing this down. Therefore, when I bring it this arm ground to the ground like this from the side, okay, here to the side, I put it like that. This can be calculated based on the rho sin theta. Okay, that's very important. Okay, therefore the whole R, if I use this when I rotate this using the phi, the rho, okay, here in this direction using a theta, then I get, okay, R equals to rho to the sine phi. Okay, now I'm building this coordinate system according to this one. Okay, according to this one. Okay, so far I hope that you can see what I'm trying to do here. Okay, this is similar to the R. Okay, this is a combination of the R. You can imagine something like this: R cos theta, R sin theta. You just imagine R, but only small changes that I'm making here is this: introducing one arm system calculation. Okay, one arm system calculation. Therefore it will be used rho to the sine phi. Okay, now with that, let me explain to you how am I going to build the calculations of this. Okay, the first part, I want all of you to understand the simple logics of this. Okay, we go back to the same logics that we use for the polar coordinate system. Okay, polar coordinate system. Okay, we take a polar coordinate again. I'm drawing the polar coordinate here. Hopefully you can see this. Okay, still we use this theta again. Okay, d theta. Okay, I can understand the theta because for the horizontal side, for the horizontal circle, you can say this d theta. No problem. Okay, what is this? This arm. This is the arm using r rho sine phi. Okay, it's a r. We are still referring this r, but actually the r is a phi sine. Rho sine phi. Okay, now in this case I am chopping a little bit again. Same logic, dr, right? Still we are using the principle of dr, but the whole thing actually sorry, I can I say this? Okay, okay, because okay, I cannot okay, the model that I wanted to but we losing the whole when I place it this. Okay, this is an arm. Okay, I place it this. Okay, if I wanted to go calculate in the inside, I need to use the phi by sine theta, right? If it is a small size, but the whole thing, if I take it this, the whole thing is still phi, right? Therefore this is a d phi, small one. Okay, here the whole thing is a not a phi, rho. I always confused with this. Okay, now this one whole thing is a rho, this part is a d phi. But I wanted to go and calculate the internal calculation here for this r. Okay, it's basically controlled by the phi here. Okay, therefore here this one will be r theta. We use r theta concept, r d theta. Okay, we agree. But what we agreed here, r is a this one. This one is a sine phi, okay, d theta, okay. The length of this, the length of the whole thing is basically, you can see it's a 90. It's some of you can understand this. What I'm trying to say is actually is it wrong to say r rho phi sine theta? No, the whole thing, when you fall it into the sine phi, you see the phi is a 90 degree. From here it's a 90 degree. Okay, if it is a 90 degree, you get phi back. Okay, don't okay, can I say this as a phi, rho to the sine phi? Yes, but you see on the axis base here, when I bring it that to the horizontal line here to the coordinate system called xy plane, this one is automatically become 90. Okay, this one become 90. Therefore is what you will get is r equals to rho, right? That's why I'm calculating this in a horizontal way, whereby I'm still using the r logics here, but since we are using for the horizontal calculation here, we just get this r equals to rho to the sine 90 degree. Okay, remember, again come back here, see, it's when phi here it's go down to this point, it's become 90 degree. Okay, now I hope that you got it here. Okay, I hope that you got it what I wrote here. Okay, now what I'm trying to do, I'm just pulling up bit. Okay, I'm pulling up here. Okay, this part is something that a little bit confusing. Okay, it's a little bit confusing. I'm pulling. Pulling means I'm creating the first surface here, this surface here. Okay, this surface. Okay, I can pull up some more. This surface is outside. I'm using phi. Okay, I'm using phi. Therefore, it's a arm. That which I'm referring to here. Okay, is arm. You see this. Okay, okay, this way is easy. Okay, it's a slightly I'm pulling from the ground. I'm referring to this surface here. Okay, therefore this surface, when I try to pull up to the up, what am I using here? Okay, I'm still using the same logics, rho, okay, but d phi. Okay, can you get me? Okay, not clear. Okay, not clear. Why is it phi d phi? Okay, now you see, you just concentrate this first. Okay, for this one, okay, if the case is x and y, for the x and y, if it is theta, d theta, we are using here r d theta. You can understand this, right? You can get this circumference, no problem. Okay, now I'm saying this, you are looking from the perspective of what? Actually, you are looking at the perspective of x and y. Now you look at this in this dimension here. I'm looking from the perspective here. Okay, perspective here. This is phi. Okay, phi is actually coming. Okay, the changes like that. Okay, like that. The phi is actually coming down. Remember, the phi is coming down. Okay, if I wanted to calculate anything, it's basically I'm calculating based on this. But I wanted to show you the when I pulled here, this one imagine this is a, you imagine this is a d phi, and this is a rho. Then you know, okay, very simple. I can understand this is rho d phi, not a theta. Okay, phi. Okay, with this, now you know, can I combine together what I will get here? Okay, the dv is dx, dy, dz. Okay, and okay, this is similar to this one here times this. You again r d theta. Okay, I just say r d theta. R d theta means here, we already just say, I already defined to you, r d theta is referred to this one. Okay, and up here phi d theta. Okay, phi d theta. Can you see that? Phi d theta. And d phi, not the d theta. This is d theta, and changes of this d phi, d rho. I sometimes I mispronounce this d phi la, d rho la. Okay, the logics here that I want you all to see this. This is what I want you all to understand. Okay, this one is a vertical. Okay, sorry, horizontal. This refer to vertical grow. Okay, vertical what you call circle. Okay, kind of circular is a vertical, and this one of course d phi, inside, moving inside and up. Therefore r, we know basically is r is a rho sine phi d theta, rho again, okay, d phi, okay, d rho. Okay, if I just bring it up here, therefore the dV can be written as, okay, combine phi, okay, sine phi d theta d phi d rho. Okay, we already found the logics of this. Done. Can you see that? Okay, spherical coordinate ready. Wow. Again, can you see that? Okay, take a deep breathing. I know some of you, oh sir, what are you talking? I cannot get la. Okay, give me, okay, it will take some time for you to understand again. I just quickly one more time I repeat this work. Some of you may get bored. Okay, I can't help it. Okay, again I repeat the whole thing again. Just quick one, very quick one. Okay, X, Y, Z, based on my experience lah. Every time student will say we don't understand, please explain again. Therefore I am doing the task again. Okay, this is phi. Okay, this is rho. We are using one arm system. Okay, this one I bring it here. Okay, most of you can get this. Okay, I can understand that. Okay, sorry. Okay, I can Z. I am representing the Z with the phi cos. Okay, clear. Sir, this one clear. Done. Okay, now I bring it this down. I'm bringing this down. Okay, I'm bringing this down. Then this one is this. Okay, remember this line. Okay, this line. This one is rho sine phi. Okay, therefore I call this one as R rho sine phi. This is referred to horizontal. When you see, depends on which horizontal line circle that is go, the sign. See, very important, the sign is referred to this phi, you know. Okay, and at exactly the point X and Y, this line, if it is fault, you get a phi. But let's say in a half of this, half here. Okay, remember, if in any hemispherical, okay, you have the middle, and you may have here, remember, this circle, this circle, this circle. Okay, this is controlled by sine phi. Okay, here if the arm is this, of course you know the arm is there. Okay, the arm is here. Let's say here, okay, once you use this, you need to use the coordinate system of this. Remember, okay, you need to use the coordinate system of this here. Therefore, you need to use a sine S for the phi. Therefore, it changed. But exactly in the middle, okay, it's a 90 degree. If it is a 90 degree, you get a phi back. Can you see that? Okay, small changes, but it's moving around. It's moving around here. Okay, if it is a 90 degree, yes, you get a rho. Okay, if it is R equals to rho sine 90, you get a this. At this point, let's say R rho sine 60, then you get a different, right? Rho something. Okay, therefore it's changing. Okay, the size will be changed because, of course, very practical, right? How can the radius here and here can be same? Cannot, right? Impossible. Here definitely it becomes smaller and smaller. Okay, therefore sine will determine this. Okay, I hope that you can grasp these logics. Okay, with that, horizontal, this is horizontal determinant is R. Okay, for the horizontal determinant is R. For the vertical determinant is this. Okay, the vertical determinant is this. Okay, now with that, okay, we just quickly will sketch this. I'll sketch this one. Okay, you imagine this is a d theta. Okay, horizontal. We are talking about this standard horizontal here, d theta. Here also theta same. Here also theta same. Theta same. Don't worry about the theta. Theta is always same here when we move up, down, up and down. Therefore, theta is same. And here, I'm taking the horizontal exactly, rho, and okay, this one is d rho. Okay, what is this? It's a r, remember. It's a completely, if you take it here, this portion. But for the other side, what about the other side? Of course, we are using r. R rho sine standard, okay, phi. Therefore, when I take it standard, no problem. But here, we are using rho r theta, sorry, r d theta, which is a rho sine phi d theta. Okay, this one, the circumference. Okay, now I'm pulling this up. Is pulling is a kind of, okay, kind of curve is exists here. Because it's a spherical, right? It's a spherical. Okay, if I take, can you see that? It's a spherical. Okay, when I pulled up here, can you see this? Can you see this or not? Okay, this one, okay, when I see this pulled here, can be referred as rho to d phi. Agree? Okay, no changes into that. Rho never change here. Okay, when rho referred to this side on this particular point, it never change any point. Can you see that? It never change. But horizontal, yes. For the horizontal, it should change. Okay, now we got this two. Okay, combine together. Okay, you see, you take a small, it's a kind of 3D block already. Can you see that? It's become a 3D block automatically. Okay. Okay lah, it's a 3D block. It's look like, okay, it's a 3D block here. Okay, therefore when you start combine, okay, you will get rho sine theta phi d, okay, times with that d phi d rho. Okay, organize back, you will get a okay, d theta d phi d rho. Okay, done. Now you know the formula already. You can create your own. Okay, you can create your own these things. Now with that, just quickly I'll go to the example. Okay, I'll quickly go to the examples. Okay, I'll go to the example. Okay, the example number one. Sorry, I need to write the property of the coordinate system. I forgot to write the rough coordinate system here. This is very important for you to understand. Okay, again I write the things as a new. Okay, repeat few times for you to recollect back. Okay, here. Wait. Okay. Sine phi, which is equals to r. This is z rho cos phi. Okay, when you come to the ground, you are using theta. Okay, theta, which direction? Okay, you can use a positive, but this one coming down to this one here, vertical base. This is a vertical base. This is a horizontal base. This one is horizontal. We are horizontal based. This is a vertical based, and x, y, and this one refer to same r. We are bringing down to this, right? Okay. Now the properties of this is r rho sine phi. Okay. Z is a rho cos phi. x r cos theta. Okay, you just use rho sine phi cos theta. Phi is different, huh? Again y r sine theta, rho sine phi sine theta. Okay, what about rho? It's a combination of x2, y2, z2. Okay, can you see that combinations here? Okay, this is what you will able to perform here. With that, we have done. Okay, and dv is a rho 2 sine d theta d rho d phi, or you can change accordingly. Okay, with that we have done vertical and horizontal. dv important, later I will change, or this is you need to master the skill. See, I'm teaching the how to create, not remember. If you start remember, I'll think you will gone lah. Okay, you cannot remember. This is you should able to create by yourself, because okay, therefore the spherical creations, okay, the arm spherical creation works based on this. The range is something it will do, the creation is like that. I'm trying to make it like a little bit like a elliptical kind of things, huh? Okay, actually when you take a range, the range works like this. The rho will go 0 to rho. It's very clear. The theta range will go 0 to 2 pi. Understood? Okay, it's understood. When you create this, you want to create any spherical, it's not a spherical anyway. Okay, but you should use this. Okay, the rho should be 0, because it's every single point is go inside, you know, this one. What about phi? How much phi can go? How much phi can go? See, okay, you imagine this is phi, we are using this is a phi. Okay, the phi only can go up to here. See, the phi can go like that. Okay, can go like that. Here, up to here only. Okay, the phi can go up to here only. After that, its circle is the same, no point. Therefore, the phi can go 0 to pi only. Okay, can you understand this or not? Okay, again, this one, it will go here. The row can go inside. Okay, inside it can create many layer like that. Okay, many small spherical. It can create many small sphericals. Okay, small sphericals. Okay, this it will create. Okay, one spherical inside one spherical. You imagine like that. Okay, this like a too many small sphericals that it can create. This one. What about this? This one, it will create different type of these things. You see, this one is a small spherical, but it's go inside, you know, go inside. It will able to create like that. But this one able to create this way. Okay, vertical base creation. Okay, the theta can create vertical base circles. Okay, this one you can see it's a total, right? Okay, it's a total creation for this. And the phi only control to 0 to pi. It's a very important, I am stressing this. 0 to phi only. Okay, because it able to go up to here only. It cannot go up here. Okay, it cannot go up here because it's referred to the same. Okay, same reference. Okay, you know, right? After 90, you use you know these things. You see, for example, sine 90. After that, you go for the sine. For example, 91. Actually, you are referring to what? It's already you go to the negative ready, right? You go for the 100, for example. Okay, you are using what? 1. Okay, once is you go beyond that it's already negative, you start using something and positive, for example the cos. For the cos and sine it works different, but I'm trying to say it's moving into different direction already. After 180, you see, it's go different. After 180 you start using 182, 190, then it's all negative already. Okay, the solution will be 90 negative. Therefore this is the range that I want you to remember. Okay, the range that you can use to form the spherical. Okay, with that I'll show you examples for the spherical. Okay, spherical examples. Okay. Okay, with that I think I should start with the spherical examples. I don't have the spherical example with me now. Let me see, am I having any spherical example? Okay. Okay, I will continue for the spherical example later. Okay, thank you.